So for the first day of trig equations, we're going to talk about specifically ones where your variable is written once somewhere in the problem. We will get into more complicated types as we go, but everything you see today is only going to have your variable written one time somewhere, and I'll show you what that looks like as we go. Here's just some steps so that you can have those. Feel free to write these down if this will help you. The first thing you're going to do is get your variable by itself. So you're going to add, subtract, divide, whatever it is you do to isolate your variable. Then you're going to do your arc function, because really your variable is going to be trapped inside of a trig function. So you might, after step 1, have something that says sine of x equals 1/2. And then step 2, you're going to get that x by itself. And then you're going to actually figure out the range of the values for your solutions, and we'll talk about that as we get going. So this is a prime example of what it looks like if your variable is written once. I have one trig function with a variable inside of it. And that first step tells me to get my trig function really by itself. So here you're really leaning on your Algebra 1 skills, and you're just going to subtract that 1 over and divide by 2, and you get that sine of x equals -1/2. Now problems like this are ones that are not new, and really today the nice thing is we just get to review how we did problems like this all throughout. We've done these constantly throughout the year, and we get to just practice that one more time with a little bit of algebra on the front end. You are going to give me your answers in radians. Your guideline up here tells you it wants it to be between 0 and 2 pi. But we're really just going to figure out what in radians gives me sine of what gives me -1/2. And so to go through that, this is where we're thinking about our special right triangles. Since it is a 1 and a 2, that means it is a 30, 60, 90 triangle, with your 1 being opposite your 30 and your root 3 being opposite your 60. Since it's sine, you want whatever's opposite, so that tells me my reference angle is pi over 3, but again, we want this in radians. So my reference angle is pi over 6. Sorry, my reference angle is 30, which is pi over 6. Once you know your reference angle, you need to think about your quadrant. Sine is negative here, and sine is negative in quadrants 3 and quadrant 4. So that tells me that my two answers here are whatever is a pi over 6 reference in those two quadrants. In quadrant 3, it's 7 pi over 6, and in quadrant 4, it's 11 pi over 6. And that is done. This one's going to be similar. Feel free to give it a try before I talk about it if you want to, or just listen to me going through it. So again, our first step is to isolate our trig function. So I'm going to add root 3 and divide by 2. So I get that the cosine of x is equal to the square root of 3 over 2. Again, then you're thinking about which special right triangle this is, and this is the same triangle as the one we just did. Cosine needs adjacent over hypotenuse, so it's still actually this 30-degree reference angle, which again in radians is pi over 6. We do need to consider where this is at. Cosine is positive in quadrants 1 and 4. And so your answer for x is those angles in quadrants 1 and 4. So in 1, it's pi over 6. And in 4, it's 11 pi over 6. This one here is going to make us continue to kind of dive into our algebra before here. We want to get this tangent of x by itself first. So we will do add the 1, divide by 3, and you get tangent squared of x equals 1/3. And you do need to get tangent by itself. This is the exact same as solving x squared equals 1 over 3. Here you would square root both sides, and you would get x equals 1 over root 3, and if you remember back to algebra 2, it does need to be plus or minus. So in this problem, it's really just tangent of x equals plus or minus 1 over root 3 when we square root both sides. When you do this, you still need to keep going like we have been and figure out your special triangle first. This is still the same special triangle. It will not always be the same one, but it's one of our two, so it's pretty likely. Tangent is opposite over adjacent, so the 1 over root 3, which means my reference angle is still that 30, or the pi over 6. But we now have to think about where it is. Because it is plus or minus right here, it is where tangent is either positive or negative, which tells us all 4 quadrants. Okay, so you have to give me all 4 answers here because, again, it could be tangent could be positive, tangent could be negative, it doesn't matter. So my actual answers for this, for quadrant 1 is pi over 6, quadrant 2 is 5 pi over 6, quadrant 3 is 7 pi over 6, and quadrant 4 is 11 pi over 6. All 4 answers are totally valid. Moving on to this one, I would suggest that you give it a try first and see how far you can get, and then, like always, play the video to make sure you are good to go. So here we want to get cosecant squared by itself by dividing by 2. So we'll have cosecant squared of x equals 1, and then you do need to square root both sides, and so you get cosecant of x squared of 1 is 1, but now it's just plus or minus 1 because, again, we square rooted both sides. Cosecant, being 1, this is my hypotenuse over my opposite because cosecant is the reciprocal of sine. I do not have a special right triangle with a hypotenuse of 1, so that tells me that this is a quadrantal. What we do then, remember, my hypotenuse is always my radius, opposite is always my y value, so I need to think about which of these 4 ordered pairs, and I'll write all 4 of them out for you, have a y value of 1 in them, or negative 1. And if we look of these, what has a y value of positive or negative 1, again positive or negative because we square root it, are going to be these 2 vertical ones along the y-axis. The 0, 1 is pi over 2, and the 0, negative 1 is 3 pi over 2. And so those are my 2 answers for x. Okay, now we're going to get into sum with a number in front of the variable inside of your trig function. And these really work about the same way, but we're going to have to talk through a little bit how you find all of your answers here, because that is where the tricky part will come in. So originally you try to get your trig function by itself, which here it is already by itself. And so then we start thinking about sine of what gives me 0. When we wrote this back in chapter 1, how we would always rewrite it is whatever was inside my trig function is now equal to the arc sine of 0. And what I want you to remember here, before, inside our trig function was just x, so when we evaluated it, what we got for our answer was just equal to x. Now when I evaluate this, it's going to be equal to 2x, not x, and that's going to be an important change as we move forward. Otherwise, doing this is exactly what we were doing, like here when we were evaluating this trig function and finding these answers over here. Okay, so to do the arc sine of 0, it's 0 over 1. This is my opposite over my hypotenuse, which this is a quadrantal, so it's going to be my y over r. And so I do need to know which ones have a y value of 0, which means it could be positive or negative 1. Again, thinking about those 4 ordered pairs here, and the ones that have a y value of 0 are the ones along your x-axis. Typically, you would then just tell me 0 and pi, but that is not where you're done now. This is where we do have to keep going, and there's a few things that change. The first change is you're going to have to give me more answers than just this because of the fact that there is this 2 here in the problem. And what we're going to look at up here, it tells me that any value for x needs to be between 0 and 2 pi, but I have 2x here. So as I'm evaluating, I need to give me all the answers for a 2x. And we can think of this with our inequality. If I want to make this x be a 2x, I would have to multiply everything by 2. So 0 times 2 is still 0, so my lower bound is still 0. But 2 pi times 2 is now 4 pi. I have to give, 4 pi is 2 revolutions. You will actually always do the same number of revolutions as whatever this is here. But you have to give more answers because otherwise you're going to miss some in that first region when you finish the problem. So what we're going to have to do is we need to find coterminal angles with these 2 answers that I found. To find coterminals, remember that we add 2 pi to our answers. So 0 plus 2 pi is 2 pi. And then I'm going to do pi plus 2 pi, which is 3 pi. So I need to have all 4 of these answers here These are all of the answers that I get between 0 and 4 pi, or again within 2 revolutions. Why that's important is right now I'm not set equal to x, but I'm set equal to 2x. What I'm about to do is actually solve this, which is going to shrink all of my numbers to be in this range for their x value. To solve this right here, we need to divide by 2, and so you're going to divide every single number by 2. 0 divided by 2 is 0. Pi over 2 is just pi over 2. 2 pi divided by 2 is pi. And then 3 pi divided by 2 is just 3 pi over 2. That got me 4 answers. Again, all 4 of these are within this original domain that I requested it to be. And had I not gone further and gone to 2 revolutions with my 2x answer, I would not have gotten these that are perfectly valid answers. So it is important that you go an extra revolution. And then when you divide, I promise they will all end up within that first bound that you were given. But we're going to try a few of these just to make sure we're okay here. So, first thing you need to do is just get cosine by itself. So we're going to have cosine squared of 2x equals 1/2. One thing I do want you to notice here, all these 2's get kind of confusing. So please be careful about your sizing and making sure you know which one's a squared, which one's a coefficient, things like that, because a lot of 2's are happening. We do have to square root both sides, and so you end up getting cosine of 2x is equal to plus or minus, because we square rooted. Square root of 1 is still just 1 over root 2. This is going to give us a 45, 45, 90 triangle, because this is my adjacent over my hypotenuse. So my reference angle here would be that pi over 4. And so again, I'm evaluating this because it's positive or negative, all 4 quadrants. And so 2x here, because again, that's what I isolated when I do the arc cosine of both sides, would be pi over 4, would be 3 pi over 4, 5 pi over 4, and 7 pi over 4 in that first revolution. Again, if I was just solving this, normally this would be my answer, but because there's this 2x here, I have to keep going. Because of the 2x, I need to do 2 revolutions, so I'm going to add 2 pi to each of my original answers to get their coterminal in the next revolution. It is important to get a coterminal angle here. A common denominator to add to get the coterminal. So remember that all of these will really be 8 pi over 4. And so when I do that addition, I'm going to get 9 pi over 4, I'm going to get 11 pi over 4, 13 pi over 4, and 15 pi over 4. That's going to give me 2 revolutions of answers for this problem. Your last step then is to divide all of this, I'm just going to write it one big time, by 2 to actually solve for x. The algebra, how it's going to work here, is going to be pretty similar for each of them, so I'm just going to write out one of them to talk you through it, and then we'll kind of generalize what's going to happen. So we're really doing pi over 4 divided by 2, which is really just a complex fraction. So I'm going to put that 2 over a 1. Your LCD here is a 4 then. So I'm going to multiply both things by 4. These will cancel, and I get pi over 2 times 4, or 8. What's going to happen here when I do that division is that same thing would happen each time. And so all of my denominators are just going to turn into an 8. As you do this, make sure if anything does, oopsies, I skipped 9. If anything does simplify, do simplify it here. It doesn't. Sometimes it will. Just keep an eye out for that. Don't write 2 pi over 2. Tell me the simplified answer. And this is my final answer. You will sometimes have one with more and more answers, just kind of depending upon the problem. Okay, this will be the last one we work out here. Again, feel free to give it a try and see, and then play the video when you're ready to go through it. So to isolate my secant, I really just need to square root both sides, which is going to give me secant of 3x equals plus or minus 1. And again, now I need to focus on doing this, the arcsecant of plus or minus 1, so that I can actually evaluate this. Secant is the reciprocal of cosine. So this would be hypotenuse over adjacent. Again, this is a quadrantal, so this is radius over my x-coordinate. So I have an x-coordinate of plus or minus 1, because remember that plus or minus always goes there, which does tell me my y value has to be 0. And those two ordered pairs would give me 0 or pi. Then, because of this 3, I do need to do 3 revolutions. So I'm going to go through, I'm going to add 2 pi to each of these, which gives me 2 pi and 3 pi. And then I'm going to do it a second time because, again, I need 3 revolutions. That only gave me 2 so far. So I'm going to have 4 pi and 5 pi. Then, again, this is set equal to 3x currently. So I do need to go through and divide everything by 3 to get x by itself. And that's going to give me 0, pi over 3, 2 pi over 3. This next one would be 3 pi over 3, which is what I was referencing before. Just simplify that, tell me it's pi. And then 4 pi over 3 and 5 pi over 3. And that is my final answer.